In this video, we are going to discuss about linear polynomials. So linear polynomials are basically just algebraic expressions. So now in this chapter, we are going to see this in details about what are linear polynomials and how to solve them. So introduction. So let us imagine that we have a rectangle. We have a rectangle, and let us imagine that one length is 10 and the other length, and we don't know the other length, so we can take it as any letter such as x. Now we can put any value at x so that we can get the area of the rectangle. So for example, if we put x is equal to 1, then the area will become 10 times 1, which is equal to 10. Similarly, if we put x is equal to 2, then it will become x times 2, which is equal to 20. So in general, for any breadth x, we can say that the area is equal to 10 times x. So now we are going to see another thing. So this is known as a linear polynomial. So this is a linear polynomial. So now we're going to see it in detail. So now we're going to see what are terms. So let us imagine there's an expression 4x plus 5. So 4x and 5, which is separated by plus or minus, these are known as terms. So in this expression, the terms are 4x and 5. And then we are going to see what is constant. Any constant value. For example, in this example, you can see here it is 5. Or for any other expression like 6x plus 7, we can see that the 7 is the constant term. It is not multiplied with any variable. It is multiplied by x power 0, which is just equal to 1. So we just write it as 7. So in this expression, the constant term is 5. Now next we are going to see what now next is expression. So basically expression, it's a bunch of terms. It's a bunch of terms, like a group of terms. To be more precise, it can be a group of terms. For example, this is an expression 4x plus 5. It contains multiple terms. So any algebraic expression which has a variable. Talking about variable, a variable is basically a part of a term which can vary, and it is represented by any letter, and be represented by any letter such as x, y, z, a, b, c. So like this, we can see the different terms, like these different terms used to define an expression, like terms, constant, and expression and variable. Now next up we are going to see a different thing. Now we are going to see what is a degree. What is a degree of an expression. So basically a degree of an expression shows the highest power of the polynomial. But there are also some rules. For example, degree cannot be fraction or negative numbers, or negative numbers. Degree can only be whole numbers. So let us see an example. Let's say we have an expression x square plus 3x plus 5. So what is going to be the degree? We can see that the highest degree on the variable is 2. So the degree of this polynomial is going to be equal to 2. The degree of this polynomial is going to be equal to 2. Let's see another example. Now let us say we have 3 times root x plus 1 by 3. So basically root x means 3 times x power half plus 1 by 3. So we cannot tell the degree of this term. Now let us look at another example. Root 3x plus 4x plus 4x square plus 4 by 3 x cube. So the degree in this is going to be the highest power, which is going to be 3. So the degree of the polynomial is 3. So now there is also a new term known as univariate polynomials. So basically it means any polynomial which has only one variable. These are known as univariate polynomial. For example, let's say 4x plus 5, 2x square plus 4x plus 5. These all are univariate, whereas 4x plus 2y plus 6 not univariate, or 4z plus 3y plus 2z plus 2x also not univariate, but 4z plus 5 univariate. And now we will see what does linear polynomial mean. Linear polynomial. So the chapter name is linear polynomial. So a linear polynomial is a polynomial whose degree is 1. Whose degree is 1. So now we will solve some questions. So we are asked this question. So this is from exercise. This is from exercise 2.1. Exercise 2.1. First question. First question. So we are asked to find the degrees of the polynomials. So this is not very hard question. So we, in this first polynomial, we can clearly see that the highest power is 2, and this power is 1. Whenever we see any term like 5x, 4x, where there is no power written, so we imagine that this power is a 1. And if this is a constant, then it basically means that it is variable to the power 0, since anything powered 0 is 1. So the answer of this is going to be degree is 2. Now next we can see this is y power 3, then 2y raised to the power of 1 and minus 1. So the highest power is 3, so we can write here degree is 3. Now we are given here minus 9. So we don't see any variable, but we can imagine a variable here. So let us imagine that there is x. So it is x powered 0. We said here, we learned here that if there is a constant term, if constant term, then the exponent of variable is going to be 0. So the answer is going to be degree of polynomial is 0. Now 4z minus 3. So we cannot see any power here, but there is a variable. So this is going to be 1. If there is a variable and no power is written, then we imagine it to be 1. So degree of this polynomial is 1. And with this we got our answers. To the first exercise. Now moving on. Now we have another question. We have another question. What are the coefficients of x square and x cube in the polynomial x raised to the power 4 minus 3x cube plus 6x square minus 2x plus 7. Another question from the exercise. So basically coefficient means, so this is the coefficient, and if we don't see the coefficient, it is usually labeled as 1. Coefficient is basically the multiple of the variable, and yes, the coefficient of x cube and x square and x, basically which have different powers, will have different coefficients. So these are basically multiple of variables. And when we write coefficients, we also count the minus. We also count the minus in all of these. So we are asked the question, the coefficient of x square and x cube. So So let us first find x cube. So we can see here is x cube and its coefficient is going to be -3 since it is multiplied by -3. So let us write here coefficient of x cube is -3. Now let us see the coefficient of x square. So we can see that it is +6. So we don't usually write +6, we just write it 6. So coefficient of x square is 6. And with this, our another question is complete. Now moving on. Linear polynomials. So now let us imagine another scenario. Let us imagine that we have a bank account. So this is the bank. You come here and give them rupees 500. And they say that we will add 150 every month. So we can see that it is added constantly every month 150. It is not changing. This is constantly changing. So we can now see a table here. We can plot a table. So this is going to be months and money we have. So on month 0, the month we deposited this money to the bank, we have 500. And then after that, on month 1st, we add 150 to it. So it's going to be 150 plus 500 plus 150 times 1, which is equal to 650 rupees. On month 2, we're going to have 500 times 500 plus 150 times 2 is equal to rupees 500 plus 300, it is 800. So now we can plot for any month n. Let us imagine that this man puts it for n months. Then what will be the value if he gets it back? So it is going to be initial value 500 plus the bank will provide 150. So 150 times n, which means, so now we can write here for n months. For n months, amount of money will be 500 plus 150 n. So this will be our equation. This will be our expression. Now we are going to see what is a linear expression. What is a linear expression? So what is basically a linear equation? In linear equation, let us imagine that we got our expression 500 plus, me clean it, 500 plus 150 n. So let us imagine that y is the amount. Y is the amount we get back. So we can write y is equal to 150 n. Basically, linear equation means that it has a polynomial with degree 1 has an equal sign and another linear equation on the other side, then we will call it a linear equation. Now we are going to see another thing. Putting values or basically putting values in polynomials. So now let us see. For example, we have an expression 3x plus 12, and we want to know what will be the so let us write it in the form of equation. Y is equal to 3x plus 12. What will be y for the value, for different values of x, for different values of x. So let us first put x is equal to, what can we put? We can put 2. So now we can replace this x with 2. So it will become 3 times 2 plus 12, which means we can write this as 6 plus 12, which is equal to 18. So on putting x is equal to 2, y is equal to 18. Now let us do another. X is equal to 6. So now let us put 6 in the place of x. So it is going to be 3 times 6 plus 12, which is equal to 18 plus 12. 18 plus 12. So in the total value will be 30. So on putting x is equal to 6, we get y is equal to 30, and for different values of x we can get different values of y. So we have just discussed linear polynomials and putting values and real life example, one real life example and linear equations. Now moving on, we have a question. This is from exercise 2.2. Let me write here. This is from exercise 2.2. The present age of Salil's mother is 3 times Salil's present age. So let x be the age of Salil, which means present. So let us first write the scenario for present. Age of Salil is equal to x, and then we are said here that a present age of Salil's mother is 3 times that of Salil's present age, which means age of Salil's mother is going to be equal to 3x. So this is for the present. Now what will happen after 5 years? After 5 years we are given another situation. After 5 years their ages will add up to 70 years. So first of all, let's just rewrite this. Age of Salil, after 5 years it will be x plus 5, and age of Salil's mother is going to be 3x plus plus 5, and we are given, and now we can see that there is a polynomial found, since their ages will add up to 70 years. So we can clearly write x plus 5 plus 3x plus 5 is equal to 70. Now we can add the like terms to get 4x plus 10 is equal to 70. Now subtracting 10 from both sides, we get 4x is equal to 60, therefore x is equal to 15. So based on all of this, we can say that Salil's present, may clear up some space. Salil's present age will be 15. Salil's present age is 15, and his mother's age will be, Salil's mother's age will be 15 times 3. 15 times 3, we are going to get 45 years. And by this, we can solve other questions also. Moving on, linear growth and linear decay. So in the previous example, in the bank example, we saw linear growth, that in the first month we had 500, then in the second we had 650, and so on. So this is linear growth, since it's added by 150 every time. But this is new term, linear decay. So linear decay means that it is losing value, decreasing over time. So for example, in the textbook we are given an example. So let us example, there is a mobile phone. So this is our mobile phone. Let me draw it a bit better. So in the last example, we discussed about linear growth. So in the bank example, that it grows, because that is money was growing over time. First it was 150, then it became 650, and then 800, and so on. But what does linear decay mean? Linear decay means it's losing value, decreasing. So here we wrote the formula, 500 plus 150n. So now we are going to replace this plus with a minus. So we will get, so let us see another example. Let us imagine that we have a car. And initially it was bought for rupees 3.5 lakhs, and every year it loses its value by, let us imagine, 5,000. So on the year he bought, let us again draw a table like the previous example. Let us right here, year and value. So initially the value in the year 0, the year he bought it, it was 350,000, 3.5 lakhs, and in the first year it became it lost its value by 5,000. So this can be written as 3,45,000. So this is, it's going to be value, this is basically 3,000, 50,000 minus 5,000. So we are going to get this value. So we can see that its value is slowly starting to decrease, and similarly in this second year we see that it is going to become 3.4 lakhs. So it lost its value. So this is basically linear decay. It's linear because it loses its value constantly 5,000 rupees every year. Now let's see next. We have got another question. This is from exercise 2.5. So a gym charges a fixed monthly fee. So I forgot to mention one thing, that if any linear equation can be represented in this form, y is equal to ax plus b. So if this says that this is the fixed monthly fee, we can say that this is going to be the b value, and an additional cost per hour for using the badminton court. So we can take hours spent in badminton court bx. So she observed that when she used the badminton court for 10 hours, her bill was rupees 800. So from this we can write one equation, that so y is basically her bill. So the bill, money in bill be y. So now we can say that 800 is equal to, we don't know a but we do know x, so we can write here 10x. We can write here 10a plus b, we don't know b. Now we can see another equation, another information is given. When she used it for 15 hours, her bill was rupees 1100. So now we can frame another equation from this. 1100 is equal to 15a plus b. In both of these cases, a and b is going to be same, and we are asked to find the value of a and b. So how can we solve this now? So first of all, from this first, so let us first give this is equation 1 and equation 2. So from equation 1, we can say that b is equal to 800 minus 10a. So this means that if we put 10a right over here, then we get b. b is equal to 800 minus 10a. Let us substitute the value of b in here. So 1100 is equal to 15a plus 800 minus 10a. This means we can put the 800 to this side, so we'll get 300 is equal to 5a, which means a is equal to 60. We get the value of a to be 60. So now we have successfully found a. So what was a? A was the rate for using the badminton court. So the cost per hour cost per hour cost per hours of badminton court A is 60 rupees. So for every hour she spent in the badminton court, she spends 60 rupees. Now, since we have found the value of A, now we can substitute in any one of these equations. So I'm going to go with the equation 1. So let us solve this. 800 is equal to 10 times 60 plus B. We don't know B yet, exact value. So solving this, we get. So solving this, 800 is equal to 600 plus B. By this equation, we get B is equal to 200. So we found A and B, and the fixed rate, the fixed price, the fixed price, the fixed fee, fixed monthly fee is going to be is going to be rupees 200. So by this we found the two values. A is equal to 60 and B is 200. Now we're moving on. Visualizing linear relationships. So visualizing linear relationships. So in linear relationships, they're going to visualize it, and coordinate geometry is going to come handy in this, in understanding this, because this also involves a graph. So this is the graph. So how can we visualize relationships? Let us imagine that we frame an equation. Y is equal to x. This means that y is equal to x, which means the value of x and y is going to be c. What is x and y? It is the coordinates, x, y. X is the distance along the horizontal, and y is the distance traveled along the vertical. So by this we can put our points. So in this, so this is 1, 2, 3, 4, and this 5, and 6, 7, 8, 9, and we can, and same goes for here. So in x is equal to 1, we get y is equal to 1. So we can put our 1 point here. And then putting x is equal to 2, we get y is equal to 2, because since both are same right now. Putting x is equal to 3, we get 3. And similarly, if we put x is equal to 9, then we also get this to be 9. And here we can clearly see that a line is going to be formed. So now in any point, if you check it, for example, if you see it in x is equal to 4, you can see that it points to 4. So basically this line represents all of the solutions that x can have for y. And same, it also goes for negative. It does not only stay here, it also goes this way. So we can also extend it backwards like this, and so on. So this is going to be our graph of y is equal to x. Now another graph that we can plot can be y is equal to, the graph we can plot is going to be y is equal to 3x. So every point we travel in x, we travel three times more in y. So let us see. 1 in the x, so it goes 3 in the y. So this is our first point. And if you put it to be 0, it starts from here. And similarly, if our x value is 2, then 2 times 3 is 6, so we're going to plot it in 6. And if we put our x value to be 3, then we get 3 times 3, 9. And we can put it here, simply put it here. Same for the negative values. If we put here -1, this value is -1, this point, x is equal to -1, then we will get -3. Can plot it here -3, and then we can go so on, and we can see that another line. We can see that another line is formed. So this is y is equal to 3x, and this is y is equal to x. So by this way we can plot a graph on the from the graph from the equation given, and this is the linear relationship. So you might have been noticing a pattern. So anything y is equal to a times x, y is equal to a times x. Visualizing linear relationships. So for this we will need coordinate geometry. We would need coordinate geometry. So how can we visualize it? We can visualize it on a graph. So this is the graph. So a general formula is given. Y is equal to x, or anything here which includes x. What is x and y? X and y is the coordinates which is provided. So for example, if we are given an equation x is equal to y, then we can put it like this. On x is equal to 0, we get y is equal to 0. On x is equal to 1, we get y is equal to 1. And on x is equal to 2, we get y is equal to 2. And then we can see a pattern. And similarly on x is equal to 5, we can see y is also equal to 5. Same goes for negative numbers. X is equal to -1, y is equal to -1. X is equal to -2, y is equal to -2, and so on. And then we can see a line is formed. And we can simply draw this line. In here and in here. So this is the line for y is equal to x. Now if we go anywhere, for example, if we go to -5, then we can see that that the y value is also -5. We go to -3, or y value is also -5. So the graph basically represents all solutions of x. For all values of x, what will be y? Now let us imagine that we have another line. Y is equal to 3x. So now for x is equal to 1 times 3, it is going to be 3. So it's going to be right over here. And similarly for 2, it is going to be 2 times 3, 6. And then for 3, it will be 9 right over here. And same goes for the negative. Y equal -1, so it goes -3 and then -6. And then we can see that another line is, we can see another line. And see another line is formed. And this line is basically y is equal to 3x. So you can clearly see that this is more steep, and this y can be also, this can be also represented as y is equal to 1x. So we can notice a pattern. Y is equal to ax. As a increases, steepness increases. So in maths there is a term. This a is actually known as the slope. Slope is basically in maths change in y over change in x. Change in x. This is going to be our slope. Now this slope cannot always be positive, so now we are going to do another example which has negative slope. Y is equal to minus 2x. This is our another equation. So now we can plot it here. So for positive x1 we get minus 2. Plot it here. And for x is equal to 2 we get minus 4. Similarly, if we go minus negative, then it will become x minus 1 times minus 2 is equal to 2, since minus times minus is plus, so this will be plot here. And similarly it continues so on, and we can see another line is formed. Which looks something like this, and you can see this is going completely opposite of this. Completely opposite. This is because so how can we prove that the slope is negative? So let us see. Change in y is 2. So we can now plug in here our value here 2. Actually it is minus 2 since it's going down, and we're going plus 1, so plus 2 by 1, and we can see since this is equal to minus 2, we can see that these exactly matches. Now we're going to see a new kind of graph. The graph is going to be same, but now it's a new concept. So now not all linear equations follow this format. Y is equal to ax. There is also some constant added to it, which is b. So let us see an example that how does b vary on the graph. So let us imagine y is equal to x plus 2. We are going simple. So on x is equal to 0, y is equal to 2. Our first point here. And on y is equal to, and then on y is equal to x is equal to 1, we can say that it is plus 2, which is 3. And this also continues, and we can form another line like this, and it also follows the rule in the negative. So we can draw a line like this. So you can see the distance. So this also goes plus 2, and if this were minus, then it would have gone down minus. So basically b represents how much when x is equal to 0. B represents when x is equal to 0, what is y, how shifted up is the graph. So now for reference, now I'm also going to draw the graph of x is equal to y. So this is what it is going to look like. x is equal to y, 1 1 2 2 3 3, minus 1 minus 1 minus 2 minus 2 minus 3 minus 3. So we can form another graph, and we can see on almost every point there is a distance of 2 points of 2 units in the y-axis, and that is because we added it by 2. Now let us see another example. Another example. Or another example is y is equal to 2x minus 3. So now we can put any value for x and plot it on the graph. For x is equal to 0, it will be minus 3. 2 times 0 is 0, and minus 3 is going to go down 3 units. Then plotting up, when x is equal to 1, 2 times 1 is 2. 2 times 1 is 2. When x is equal to 1, we get this 2 times 1 minus 3 is equal to 2 minus 3, which is equal to minus 1. So it is going to go right over here, and then this same pattern happens again, and it goes up at the slope of 2. The slope will not change. The slope only depends on this a. Slope is the a, basically. Slope will not change, only how much it will go up and down will change. So we can see that a line is formed. And you can see that when x is equal to 0, it has went down 3 units because we made it minus 3, and this was all which was in the linear polynomial chapter. So thank you.